Yes, yes. So, good evening, everyone. This is Akash Rao Mallareddy. So, I'm currently working as regional ambassador for Algorand blockchain, which is a layer one blockchain, and I'll be taking you a bit, more advanced basics to advanced in the introduction to blockchain and what exactly is Web3. So, to get the ball rolling, let me explain first the evolution of the internet. So you might think why this evolution is interlinked with linked with blockchain. I'll explain bit by step by step. So first thing is previously, like when first website came into existence, it was somewhere around 1991. First website like www dot some name, some domain name dot com or dot in or dot tech, some website came into existence. It was the web era, the web searching, everything is called Web 1.0, which is in the past. And present, we are currently in Web 2.0. And the future is Web 3.0. I'll explain one by one. The first, you need to know like the birth of internet basically. So how this internet concept came into existence. First thing, like during the world after the right after the World War, the US has launched some research projects called ARPANET, ARPANET, funded by the US Department of Defense. So their only goal is to create one network which can survive even the nuclear attack. So like there are multiple telephone lines are there, but if something happens to the lines or cables, so the message will not be reaching to the receiver, right, from this end. So they want to create one network or one technology where it can survive the nuclear attack as well. So unexpectedly, like the internet came into existence with this project. And in 1980s, like a British scientist called Tim Berners-Lee, he founded the World Wide Web. So, and as I said, the first website in the world went live, like where people can access, has went live in 1991. This is the game-changing moment in the Web 1.0 or tech industry, which is also called early internet. So people in Web 1.0 or early internet can only see the content because we don't have, the backend languages like PHP, JavaScript, React.js, Node.js, all the Flask, Django, all these technologies are not present in 1991. So at that time, which the era is called Web 1.0. So in this Web 1.0, people or the users only can view the content which is present in the website. For example, only images are there in entire website. We can only see the images. If we want to interact with the website, it is not possible at all. So it is only one-way communication. That means we can only read the messages, but we cannot write the messages. So the advantages here is even today, static web pages load very fast compared to the dynamic web pages. Static is nothing but we cannot interact with the server or the backend. And second thing is it is very quick to load and navigate using static sites. And coming to the disadvantages of this Web 1.0 era is so it is not user centric or it is not interactive basically because lack of infrastructure technologies and other support tools. For example, if we want to host a website, a static website today, we have GitHub, Netlify, n number of hosting sites. At the time, there is no such kind of provisions, and it is limited to plain text, images, and links. Rather than plain text, images, or links, we can't keep much information in the websites during early internet stage, which is also called Web 1.0. And next is interactive web, which is called Web 2 or Web 2.0. So this has begun in because of the invention of Facebook or before Facebook Orkut, where we can interact with the server, where we can chat or even do video calls or audio calls to friends who are not present in our city, in other country also we can contact them. So in interactive web, so majority of the e-commerce like Amazon, all these came into existence during this era. But the interactive web or Web 2.0 got very much viral or famous because of the Facebook. where it has more than, I mean, more user profiles are there than the total population on the world on the Facebook. Each people has multiple private accounts, ghost accounts, and some accounts we might lost the password. We create a new account like that. So Facebook became very famous, and this is the Web 2.0 era, where which is also called interactive web or the social web. We call it two ways: interactive web or social web. And what are advantages here is we can interact with the server. That means in this Web 2.0, we can read and write that data. That in Web 1.0, it's only reading. In Web 2.0, it is read and write, so that we'll be interacting with the server, with the database, and user experience is very much better compared to Web 1.0. And coming to Web 1.2, one more advantage is with integration of AI, we also get personalized content and recommendations as well. For example, nowadays using Instagram, there is a feature in Instagram where if you are scrolling reels, means at the bottom it will ask you, are you interested in this content, in this type of content? If you hit that I mean tick icon, it will be I mean marked in the algorithm, and it will analyze, and it will show the a similar kind of reels in your news feed. For example, I am liking more of car stuff, like sports car and all. So I'm liking it, I'm sharing. So the algorithm analyzes my feed, and it will give more kind of reels in my news feed in Instagram. And coming to disadvantages, like what are the main disadvantages in interactive web is, for example, if I want to buy a Nike shoe, and first thing I'll do is I'll search for Amazon, because I constantly shop on Amazon instead of Flipkart. So I set my budget, I choose my color, my brand, etc. And if it doesn't fall under my budget, even after all the discounts, I go to Flipkart. Then I'll go to other e-commerce site. Then none of the sites have matched my budget range and my selection. So I'll just come back to Instagram after some time. I'll start scrolling my news feed or post by my followers or the people whom I am following. In Instagram, after every four posts, you will be seeing an ad. Also, after every five stories, you will be seeing an ad. So, what the first thing it will be appearing on my screen in the Instagram is the same Nike shoe from Agio or any other platform which I haven't explored, and it will show some price discount for me. So how these sites are knowing what I am looking for? Because all these Web 2.0 browsers are leaking our data. So in Web 2.0, we can read and write the data, but we cannot own our data. So there is a privacy concern, and it is a centralized control, and ownership of data is not with us, and we have many privacy and security concerns. One more example here is recently, like it is very much viral in recent days. One advertisement is getting I mean pumped up in Instagram, which is called the Shinchan necklace keychain, Shinchan keychain, face changing Shinchan. If we just click the button, the face of Shinchan will be changed, the cartoon character Shinchan will be changed every now and then. So when I want to buy it, because some of my sisters or someone like that character, so if I want to buy, I'll just click that. It is redirecting to a third party site which I cannot trust. If I pay using online, the possibility is the item might not deliver to me. And the second possibility, if I use my card, so my credit card or debit card details are at risk. So it has many security concerns and privacy concerns in interactive web, which is also called social web or Web 2.0. Now, coming to decentralized web. What exactly is decentralized web means? So in Web 3. It is also called Web 3.0. So decentralization is nothing but where a single entity will not control the complete ownership or complete power of the network. So here, what happens is a user can read the data, write the data. The third one is the user can own his own data. So the best example is Brave browser. If you open Brave browser, it will showcase you like in the beginning of the Brave browser, like during COVID, It is used, it will ask us, do you want ads or not? If we opt for ads, it will give us some rewards. It will showcase some ads, and it will give us some rewards in the form of BAT tokens, BAT tokens. We can cash out those, some of my friends even got more than 10,000 rupees INR after cashing out those tokens in some exchanges. So here, what happens in Web 3.0 is it is completely decentralized. No single entity will be taking control of the data, and we will be giving our own consent. It will ask our own consent first. Do you want to, see this kind of stuff? If you are okay, then only it will be showing. So the best example between Web 2 and Web 3 is, so just take the example of any bank. So all banks in India, it might be a public bank like XBI, it might be a private bank like Kotak Mahindra Bank, or it might be some cooperative society or small, small banks, or like Paytm Payments Bank, such kind of banks, financial institutions. They need to get the approval from RBI. So what happened in the case of Paytm Payments Bank last year is there is some, issue or wrong transactions or wrong details submitted by Paytm to RBI regarding the transactions happened on the Paytm Payments Bank. So they simply cancel their Paytm Payments Bank license. So what happens here? RBI is the single point of contact or single entity which is controlling the entire network. There is no other party which can has same power as RBI. If you compare the same thing in decentralized world or decentralized web or web 3.0 era, so every person in the network, for example, let's take all these are in web 3 only. So RBI has the same power, SBI has the same power, and Kotak Mahindra Bank will have the same power. Even Paytm payment banks or even a cooperative society bank also will have the same power, which is located in a small village also will have a same power. That is called decentralization or decentralized web, example of decentralized web. So what are some examples here is, so it has complete, we will be, the users will be having complete ownership of the data. And second thing is increase security and privacy, because everything, without our consent, nothing will be tracked or nothing will be shared with third parties. And it is more censorship resistant and completely transparent because it will be in the blockchain. And you empowers users with control over their data and integrity, which I discussed earlier. And coming to the disadvantages, this Web 3.0 also have some disadvantages, like Web 3.0 is not really implemented at this moment. It is the future of us. So it doesn't have the complete infrastructure or the technologies. For example, if anyone wants to learn web development, they'll go for two stack, merge stack or mean stack, basically. So if merge stack doesn't work for them, they go to mean stack. So they have an alternative here. Similarly, in JavaScript also, JavaScript has multiple frameworks like Vanilla JS, React JS, Angular JS, like different types of JavaScripts are there, which are used for different purposes. So this kind of technologies or new languages or adaptability, interruptibility are not there in Web 3.0 at this moment. And this is less user friendly at this moment due to lack of technology, complete technology. And it is a bit challenging for a people to for non-technical users to be more specific for using or accessing Web 3.0 applications. Now, coming to centralized or decentralized. So, as I said previously, the banking example. So, centralized means it is controlled by central authority. That means one single authority or group of companies pooled together forms a central authority. And coming to decentralization, it is completely controlled by the users, all the users in the network. And centralized network, it has the data vulnerability. As I said, we have the example of uh, I mean uh, Agio, Amazon. If I'm searching for any Nike shoe, it will be appearing on a different site in Instagram or even Facebook ads to me. So in decentralized,
The audio is not clear. The audio is not clear.
hello, I'm audible.
Yes, sir.
Is it a bit clear now?
Yes, yes, sir. It's clear.
Okay. Can you also see my screen?
Yes, sir. It's visible right now.
Okay. 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 Coming to blockchain. So just think of this. So you are going for an before getting into blockchain, just imagine this. You are going for an supplementary exam at your institute, and what you will be remembering? You will be remembering your own roll number. You will be remembering the roll number before or after you, and also you will be remembering the concept which you learned to pass the exam. So just imagine this one person is consists of 3 to 4 blocks in him, 3 to 4 rows in him. So in one row he stores his roll number. In second row he'll be storing the other person's, the next previous person's roll number to check his place in the exam center and sit accordingly. And in third row he'll be storing the data. And in fourth row he'll be having his own roll number as well as the number of the person sitting in the order. So the same thing will happen in a blockchain. So these persons are equal to blocks. Each block is connected with each other like a linked list. Many of the students might know linked list, right? In one, it has two boxes. In one box, address will be stored. In the other box, data will be there. Similarly, in blockchain, there are multiple boxes. In one box, the previous hash value, which is also called roll number in simple layman terms. Let's think it is some roll number in exam center, and that hash value will be stored. And current hash, that means our own roll number in layman terms, will be stored. The data will be stored, and the block number or the person number in the seating order will be stored. So this blockchain, to be more specific, the main book example or book definition is it's a decentralized distributed ledger which will be stored across the network in multiple nodes. This is the exact definition. Let's break it down. It is decentralized. First thing, it is like we learned decentralization already. It is distributed. Distributed in the sense, for example, if someone wants to run a blockchain node, so node is nothing but a computer again here. So if someone wants to maintain the blockchain, so this blockchain is a kind of distributed ledger. Ledger is nothing but if you go to any kirana store, the people will be writing like what all items they sold, right? That is a ledger. A bit upgradation of it is if you are organizing any fests at your campus, if you keep a stall, after every sale, you will be writing it down, or you will be just marking 1111, and you will be striking off that four ones with a fifth one, so that you can have a count. Similarly, all these physical ledgers, if it is online, it is called digital ledger. The blockchain is decentralized, distributed. That means distributed in the sense it will be stored in multiple computers. Computer equal to node here in technical terms. So decentralized distributed ledger, which is stored across the network. For example, in the network of, I created my own blockchain called Akash network. So in my network, 100 people are there. That means 100 people need to join my network, means they need to have 100 nodes. Each person should have a node. That means each person should have one computer with them. In that computer, they need to run my software node program, which is called software program, which is equal to node program, so that they should run 24/7, 365 days. So they will be part of my network, and each person will be having the same copy of the ledger, same copy. For example, I am writing, I have transferred 1 rupee to Slate value. So this entry will be recorded in all the 100 computers at the same time in the same way. At this time in the world, 100 transactions are going on. So according to the first come first serve basis, entire 100 computers will be marking the ledger, updating the ledger. So this is a basic definition or understanding of the blockchain. So this stored data which is present in the blockchain is immutable. Like in tuple, which is immutable, we cannot insert the data into the tuple. So similarly, the data in blockchain is also similar to the tuple concept, which is immutable in and it will be cryptographically sealed by a block concept. In each block, there will be the current hash of the block, the previous hash of the block, and also the data will be stored. Data can be anything. It can be a payment transaction between two people. It can be an asset transaction and non-fungible token transaction. It can be any data which will be stored, and all this will be on the blockchain across all the nodes. How many nodes are running on that particular blockchain? In each block, the data will be replicated. And what are the benefits of the blockchain is it is it has more security and immutability. No one can tamper blockchain. If there are 10 blocks in a blockchain, if I want to modify some data in fifth block, what will happen is if I just add or delete a small space or even a small full stop also in the data, the hash value of current block will be changed. If fifth block's hash value is changed, it does not match with the hash value which is stored in the sixth block. If sixth block is changed, seventh, eighth, ninth, 10, all the remaining blocks will be affected. So this will be notified to other blocks in the network, and they will be deleting this blockchain from the node, and they will be replacing it with a copy of the newest blockchain. So that is why it is very immutable, and it has complete transparency and trust, because whoever have the internet can now go and check the blockchain in the real world. Any public blockchain you can check how many transactions are going on. I'll show the example how the blockchain works, and how many transactions are there in multiple chains. And it is more decentralized because no one controls this. Like if blockchain is also controlled, or even our money is controlled by central authority like the government of India. If they want to print more and more money, inflation rises. It will affect the population, it will affect all the citizens of India, right? So we'll also become some African country. We also need to buy, like, not even Africa, like I had been to Indonesia. Like one water bottle cost is somewhere around 10,000 Indonesian rupee. So that 10,000 is equal to somewhere around 20 or 30 rupees in our currency, equivalent to 1 rupee equal to 250 or 217 Indonesian rupiah. So that is the inflation there. So, and also like with blockchain we'll be having very reduced costs, and it is completely efficient and completely fast compared to all the web 2 systems. And it has the global accessibility. So let's take a case of DigiLocker. Everyone has a DigiLocker, right? DigiLocker can store your 10th mark memo, inter mark memo, or Aadhaar card, PAN card, every document which is issued by the government of India. So here, if you want to share any document outside of India, they can't access DigiLocker because there is a restriction in India. DigiLocker cannot be accessed outside of our boundary or geographic region. So if the same thing, if you develop something, some digital passport or something in blockchain, you can share it globally. It has the global accessibility, and it has complete data privacy, and it also has less fraud cases if we use blockchain. And what exactly are the types of blockchain? How many types of blockchain are present at this moment? Is first one is public blockchain, where anyone with the internet can see, can view, can even participate in the blockchain, and which is completely open to public. Second one is private blockchain. That means it has limited access. Private blockchain is nothing but it is the best example is the governments use this, so it won't be accessed by anyone outside of the organization. Next, consortium blockchain. Consortium is nothing but, for example, Mahindra, Tech Mahindra is there. They have one more entity called Mahindra and Mahindra, which manufacture cars. So Mahindra and Mahindra and Tech Mahindra are two sub companies, two companies of Anand Mahindra. So these two companies can share mutual resources or mutual one blockchain, which is called consortium blockchain. The final one is permissioned blockchain. That means there is a blockchain inside of an organization where each level can access few, resources or few features. For example, I am the CEO. I have the complete access of the blockchain, and any one of you are level one worker. That means you are the entry level worker in the company. You have access to only few features in the blockchain, few data in the blockchain. So that is called permissioned blockchain. And coming to types of public blockchain is Bitcoin, Ethereum, Algorand, Solana, Litecoin. There are more than 100 public blockchains are there. There is always a myth. People think cryptocurrency is blockchain. Cryptocurrency is not blockchain at all. So these cryptocurrencies use blockchain technology and coming these survive because for each blockchain need to survive. How they will be surviving is each blockchain has their own cryptocurrency, which will be given to users or people in the network as a reward. People started using them for trading purposes. So that's a different ball game again. So major reason why blockchain came into existence and cryptocurrency came into existence is to spread more real world use cases. And coming to the most important concept in blockchain is called consensus algorithm or consensus mechanism. This consensus mechanism is nothing but like how a person or a node is going to validate the transactions in a block in a blockchain. We can't keep random stuff, random shit in the blockchain. All transactions need to be verified properly. For example, I don't have 100 rupees in my account. I have only 90 rupees. But if I send 100 rupees in a blockchain, if it records successfully in a block, it doesn't make any sense. Each node or something need to do the transaction validation. For that, we have different types of consensus mechanisms in blockchain. First one is proof of work. Like each blockchain, each public blockchain has its own consensus mechanism. This proof of work is used by Bitcoin, also Ethereum 1.0 version, the launch version of Ethereum. So what happens in proof of work is you need to buy the infrastructure first. That means the node MCUs, all the physical infrastructure. You need to provide 24 by 7 electricity and Wi-Fi internet facility to it. So what will happen is each block, if it need to be validated, it generates a mathematical puzzle, and whoever in the sense, it's not users or people, which machine is going to solve it first will get the block reward in Bitcoin. So what is the reward here is when Bitcoin started, the block reward was P is the and RS is the unit name, right? Similarly, Bitcoin has a currency name, BTC is the unit name. So 50 Bitcoins is the reward when they launch. Every 4 years in blockchain, slashing happens. Slashing is nothing but the reward will be slashed into half. 50 became 25, 25 became 12.5. 12.5 became 6 point something. Now the current reward is 3.125 Bitcoins for validating one block in Bitcoin ecosystem. So here, what is the benefit for the nodes, people who are in the network is whoever has the highest computational resources. Like I am using 16 GB graphic card for you for playing a game. My friend is using 64 GB graphic card. So his game or his capabilities is more. than mine, right? My computational resources. Similarly, whoever has the highest computational resources, they will be able to validate it and they will be getting the block reward. That is called proof of work. They will be giving reward for the work you have done as a proof of work. And it is used by Ethereum 1.0 and Bitcoin. Majorly, it was introduced by Bitcoin. Next thing is proof of stake. What exactly is proof of stake? Proof of stake is nothing but we need to first buy the cryptocurrency and stake them. Stake is nothing but like a fixed deposit. I'm just telling in a layman term. What will happen in a fixed deposit? We cannot move the fund, right? So if we lock, it will be locked for 1 year. Similarly, here staking in blockchain means you will be staking that cryptocurrency, some X amount of X coins of cryptocurrency to validate. So whoever having the highest number of funds in their wallet, they will be able to validate the block. It is called proof of stake. Whoever having the stake, they will be having the higher chance. It is implemented or it is used by Ethereum 2.0 version, even Polygon, which is our Indian blockchain. And coming to the next one, one more consensus mechanism, pure proof of stake. It is basically used by Algorand blockchain. So what happens in Algorand blockchain is you need to hold some X amount of Algo cryptocurrency in your wallet. So like how we have our bank account, similarly in blockchain, we will have wallets, cryptographic wallets or digital wallets. So in this wallets, like Paytm wallet, we will be cryptographic wallets. In this wallets, you will be holding some X amount of algos. And what will happen here in pure proof of stake is not if you have 10 lakh algos, I have 1 lakh algos. But obviously, you will be getting more chances to validate a block. But here, the founder name is Silvio Micali. He is a Turing Award winner. It's like a Nobel Prize for CS engineers, computer science engineers. So he was a professor in MIT, Massachusetts Institute of Technology, for 40 years, and he retired. So he founded Algorand blockchain. So he founded multiple concepts like verifiable random function. This is an algorithm which will pick 10 random nodes from the entire network they have. They have somewhere around 4,000 plus nodes in their world. So they will I mean the verifiable random function will be picking 10 nodes across the this 4500 plus nodes, and it will propose a block for validation. Whoever validates it successfully, they will be getting a block reward. And next, it won't directly submit the block into the blockchain. It will pick another 10 nodes which are not the previous 10 and proposes the block again. If it passes more than 51%, it will be merged into the blockchain. So here, the player replaceability function is there due to verifiable random function. So due to this, it is completely secured. If I have 10,000 algos or half of the algo stake which is released in the market, I can't control the blockchain because the verifiable random function won't pick my node all the time. And coming to decentralized wallets, what exactly are decentralized wallets? Means just like we have our Cred wallet, the Paytm wallet, PhonePe wallet, we have like MetaMask, Trust wallet. All these are cryptographic wallets. So these wallets hold multiple cryptocurrencies. So coming to next feature called smart contracts. Smart contract is nothing but on Bitcoin we cannot write any smart contract. Bitcoin is purely an alternative of native currency. And for Ethereum and any other public blockchains, we can write smart contracts. This smart contract is just acts like your backend of the website or application, which will be helping you to build D apps. D apps is nothing but decentralized applications. Whatever you have in Play Store are called apps, applications, full form. So whatever you build using blockchain smart contract is called D apps, decentralized applications. So let me showcase the live transactions. So this is called LoRa. LoRa is nothing but one of the explorer. What is happening in the world in with respect to Algorand blockchain? Everything we can see here. So I have connected my wallet. This is my wallet, which starts with JUC and ends with CE, which is 58 characters long. We cannot remember the wallet address. We will store it and we'll be using it. And it is in testnet, test network. We have multiple networks like mainnet, which is called main network, testnet, testing network, beta network, local network is your system. So like local database, local network, testnet. This is testnet, and you can see like how many blocks for every 2.5 second a block will be added into a blockchain of Algorand. So you can see the block number, how many transactions are there. So here in this, if I open this block, block number is 51571978. There are 9 transactions. All 9 transactions are application calls. Application call is nothing but if you enter Facebook, so you enter your username and password. What will happen? The query will goes to database and check, are these credentials correct, and also are these present in our database. If it is correct, it will fetch you the details and it will make you log into Facebook. Similarly, these are someone has deployed some application on blockchain and they are testing it. This is called application call. They are doing an application call, and for every transaction in blockchain we will be having a gas fees, or we also call it transaction fee. You can see here the transaction fee in Algorand or gas fees in Algorand is same. If we transfer 1 lakh algos from account to account, it will be 0.001. If we send one algo also, it will be 0.001 only, but it will differ in other blockchains, and other blockchain also take time to confirm the transaction, but Algorand is a bit fast and very secured. So if you compare Ethereum, it will take somewhere around 20 minutes to 1 hour to complete a confirmed transaction. In Algorand, it will be just 2.5 seconds. And if you are a developer, if you know Python, you can easily build on Algorand blockchain. That is for sure. You can be a blockchain developer in future also. I opened a new block which has 3 transactions. One transaction is of payment type. One is asset transfer. One is application call. Application call, we understand it very easily. Second thing is asset transfer. Asset transfer is nothing but like if I have some digital asset, which is also called digital NFT, non-fungible token, I transfer it from my account to another account, it will show it here. And one more is payment transaction. You can see here, this is the transaction ID, this is the group ID, and from this wallet address is receiving an asset. From this wallet address is receiving the payment. All this is happening in the blockchain. This is the live data. This is the completely live data. So I am switching to mainnet here. I'm switching to mainnet. I need to first connect my wallet, then only the data will be showing. So I'll be going back to testnet, and you can see how many transactions are there. Again, in one block, 9 transactions popped up. I'm just opening that block, and all these are application calls. Like that. So this is the best example. You can also check this lora.algokit.io, where you can visualize the live transactions which are happening in the blockchain space. I'm